All right, the graph of f is shown in the figure below. It says the integral from 1 to 3 is 2.3, and then they give you a whole bunch of other stuff. Kind of skip that. What they do is they're going to throw information at you left, right, and center to try and knock you off balance. Figure out what they're actually asking you for. We want f of 3 minus f of 0. We talked about this last time. That should trigger in your mind upper boundary minus lower boundary. All right, so what we want is an integral from 0 to 3. Of what? Well, they only gave you f of x, so that's what it has to be. You'll get to a point where you're like, well, they only gave me so much information, so I have to use that thing that's there. Do you know what I'm saying? Like, occasionally they'll give you extraneous information, but mostly you're just going to use it with it. All right, so we want the area from 0 to 3. So that's going to be all of this. Now, we can do from 0 to 1, like this portion right here, because that's a rectangle, and how much is that worth? Area of a rectangle? Be 2? Coming with me there? Makes me a little nervous. Now this one we actually can't find because it's not like a triangle or a trapezoid or a square or anything. But look back through what they told us. From 1 to 3, they said was worth how much? 2.3. Did you guys see that? Accumulation from 1 to 3 is worth 2.3. Bless you. So what's the total? 4.3. D. Bless you. Graph of piecewise linear function. Okay. They throw that vocabulary at you again just to try and knock you off balance. Piecewise means it's broken into pieces. Okay, obviously you see all these line segments here. Linear means they're lines. You have a bunch of broken lines is all that is. We want the accumulated area from -1 to 4. This is essentially just finding areas. This one is above sea level. And what shape is this? Trapezoid. Let's review the formula for a trapezoid. These two, perfect. Now this one's actually right side up for the for once, and I know you're going to ask me, can't we make it a rectangle and 2 triangles? Yes, I just wanted to review the formula for a trapezoid because you do have to know that for other reasons too. But yes, you could slice this up and do the rectangle and the 2 triangles. I just wanted to review a trapezoid. So the height is 2. It's actually right side up for once. And then base 1 plus base 2. So this base is 1 and this base is 3. So what is that going to be worth? The 1/2 and the 2 cancel actually. So that'll just be 4, right? All right, so 4 for that. And then this is another trapezoid. So we're going to do that again. 1/2, what's the height? It's right side up for once. 1. And then add the bases together, it would be 2 plus 1. So what is that? 3/2, which would be 1.5. Oh, but it's not 1.5. It's actually -1.5. So what's your total area? And look how they made 5.5 an answer. So if you forgot that negative, like that answer shows up there. 2.5. So B as in Barracuda. All right, the graph of f prime, the derivative of f is shown. So, and that's usually the way they do this is they give you the derivative graph. Starting at 0, so like initial position is 0. Which of the following has to be true? Here's my advice if they do something like this for you. Make up numbers to represent the areas because it is a lot easier to deal with an actual value. Let's make something up. Can we call this like 2? For the sake of calling it something, can you come with me on that? Like, okay, this one looks to be a little bit bigger than that one. So like, can we call that 3? I'm literally just making it up. But it's a lot easier to deal with a made up number than, oh, that one's a little bit bigger than that one. You know, that's too abstract. And then for this little portion here, it's like less. So maybe let's go with 1, but it would also be -1. And again, I totally made that up. I can't find those areas exactly. I just made it up. But now when you go to compare these, that makes it a little bit easier. F of 0, well, they said if you start at 0, it's 0. Okay, so that's 0 greater than f of 1. Now, if you accumulate from 0 to 1, you would get this area here, which we said is 2. So is that true or false? That is false. All right, f of 2. So if we accumulate from 0 to 2, that would be 5 greater than, now if you only accumulate to 1, that would be 2. But see, it's easier to compare 5 and 2 than this little bump plus this little bump is bigger than that little bump. I just feel like an actual number is easier to understand. So true or false? True. Good, so we want that one. All right, f of 1, we accumulate from 0 to 1, that is 2. Greater than, now f of 3 would be the whole way. So 4. So is that true or false? False. Okay, so we want 2 only, and that is B. This is going to be almost exactly like what we did last time. So graph a function f containing 3 line segments, this thing that looks like mountains here. G of x is an accumulation function. You have to link these together somewhere on the paper. This will be on there, like 100% guaranteed. Every single year there is one like this on there. The other thing you have to be hyper aware of is, where does the accumulation start? And they tell you, but you have to just make sure you read it. Where does our accumulation start? 1. You're going to have to slice this at 1. And what I would do, my suggestion is, let's go through and find all the areas first. Then we'll have them, and we won't have to stop what we're doing later and go back and find them. Okay? So first we have a triangle. How would we do area for a triangle? Good. 1/2 base times height would be 3 times 4. So 6 for that. All right, now I'm going to have to slice it here, and this is a trapezoid. It's on its side. Like this way would be right side up. So that would be 1/2. The height is 1, and then add the bases together. So let's see, that would be 4 and 1. So 5/2, or I'm actually going to do a decimal because we're going to be adding these together and it'll be a little bit easier if we have a decimal. So 2.5. All right, how about this little guy? 1/2 base times height. That'd just be 1/2. And then this little guy, same except negative. Okay, so we do that first, and then like when we do the problem, we don't have to stop what we're doing and like go back to that. So compute g of 4 and g of -2. All right, g of 4. If you plug in 4 right here for x, you're accumulating from 1 to 4. So here, let me just point to it. If we accumulate from 1 to 4, that's all of this. What do you think? Yeah, good, because do you see how these two like cancel out? So it'll just be 2.5. And then g of -2. So if you plug in -2, you're accumulating from 1 to -2. So that's from here to here. Be really careful. Good. Why is it -6? Going backwards. Opposite day. If it was negative, we would turn it positive. Find the instantaneous rate of change. What on earth does that mean? Slope. Oh, no, not slope. I'm sorry. I said that a little quickly. Instantaneous. Average rate of change is slope. Instantaneous derivative. Good. Okay. We want the derivative of g at 1. So what they're asking for is g prime of 1. We said that g prime is f of x. So if they want g prime of 1, they're really asking for f of 1. And that graph is f. So it's really just f of 1, like the point 1 whatever, because this is the graph of the function f. So do you see that there? Like it's 1, 4. That's really all that is. But you have to be able to interpret what it's asking you. C says absolute minimum. What test do we use for the absolute maximums and minimums? Remember we played hangman last time? Candidates test. Who are your candidates? Perfect. Endpoints are -2 and 4. Now, we haven't looked at critical points yet. I kind of led you through the process last time and we did the whole everything. They're kind of just like picking this one piece out of there. Critical points are where derivative equals 0. So where does this equal 0? 3? Do you guys see that there? 3? Okay. We already did 2 of these. What was g of -2? We found it already. Yeah, we did it back in part A, -6. And then which other one did we already do? Yeah, g of 4 is 2.5. We just have to go back and get 3. So remember, where did the accumulation start? 1. We want to accumulate from 1 to 3. So that's this part. So that'd be 3. And then you just write the answer. It says justify, but the chart is the justify part. So all you have to do is say, did they ask for maximum or minimum? Minimum. All right. Absolute minimum is what? Perfect. And please get in the habit of just writing the whole thing. Sometimes on the AP exam, they ask you for, like this one said, what is the absolute minimum? So actually, if you just wrote that, you'd be good. But sometimes they ask you for just the location of it. So if you just write the whole thing every time, then you'll always get it, okay? The second derivative of g is not defined at 1 and 2. So right here and right here. We should know that without them telling us though. Why can't we get a derivative at those points? Sharp edge, remember not differentiable due to sharp edge, right? It says, how many of those, so out of 1 and 2, are where we have a point of inflection, justify your answer? Well, I'll go ahead and tell you one of them is and one of them isn't. Which one is going to be where we have an inflection point, 1 or 2? Good. G of x has, remember, make sure you start your sentence with G of x is or G of x has an inflection point at x equals 1 because, and then we got to say why. And it's an annoying thing to write, but you'll be okay. Why 1? Like what about what's going on at that point makes there be a point of inflection? G prime, that's who we're citing, changes from increasing to decreasing there, okay? Because G prime, that's your source, changes from increasing to decreasing there. You're really gonna not like writing the other sentence, but we have to do it, okay? G of x does not have an inflection point at x equals 2 because. Let's just do this verbally. Put like a ... You should write something else, but this is really annoying to write and there's not even enough space. Why is there not a point of inflection at 2? Because G prime does not change from to decreasing or decreasing to increasing. And that's what you would have to write. Come on with me. Okay. Remember, I asked, they said that's what you have to write. 5 and 6 are really similar, so I'm gonna skip number 5. I'll fill it in if you're interested in the M&M problem, but I wanna make sure I get through this and you have some time left over at the end. So I'm gonna do the party problem because I like that one a little bit better. People are arriving and leaving a party. This is a rate in, rate out question. That will also 100% guaranteed be on the AP exam. There is one every year, right? Rate in, rate out. Here's your units, people per hour, okay? So A is arriving, this is the rate in. L is leaving, that's the rate out. What do you notice about the rate out? It's constant. People are leaving at 5 people per hour, okay? At what time is the party most crowded? That means maximum, you need a critical point. That's derivative equals 0. Derivative equals 0. These are your derivatives because they are rates. So you're going to take your rate in. You don't have to do anything to it. It's already a derivative. It's already a rate. Rate in minus rate out equals 0. Derivative equals 0 will give you your critical points. Most crowded means a maximum. Here's where the calculator comes in because we can't solve that in our heads. All right. Go ahead and go to y equals and clear out whatever is in there. And we're going to type this 40e to the negative t. Do you remember how to get e on the calculator? It's the ln key, but you just have to hit second, kind of like next to the 4. All right, so 40e to the, I'm going to type negative x and then minus 5. Always start with zoom 6. Zoom 6 is standard. I'm not sure if that's good, but it's a good place to start. And then we can always adjust from there. Oh, look, I can see it. It looks kind of like it's at 2, but is it like exactly 2? No, okay, so we have to calculate that 0. You guys have been really good about this. Like, do you remember how to type that? Every time I ask, it seems like you guys know. Where do you go to like calculate that? Yeah, second trace. 0. Now I do this part manually. We think it's really close to 2 because I don't like dealing with moving the cursor and the arrows. That's annoying to me. So give me a number to the left of 2. 1, hit 1, enter. Right bound, I'm going to hit 3, enter. And then guess, I'm going to guess 2, enter. I type them manually because I don't like dealing with the little arrows. That's annoying. All right. 2 point, oh, how many decimal points do we need? 3. So 2.079. And what was our unit for time was hours. Now there's a second part to that question. How many people are there? So we need to accumulate people from 0, like when the party starts, until that time. Here's the thing. You can't type 2.079. It will not be accurate enough. So you have 2 choices. We can either store that number and do a copy paste, or you can type all of those decimals and it should be accurate enough at that point. I will go through it however you would like to. Do you want to store and do a copy paste, or do you want to just type all those numbers? So, okay, so here's what you're going to do. Quit out of there, go back to the home screen. Because we just calculated that, it has X stored as that number for right now. If you don't mess around and do anything else, hit X, enter, it'll bring it back. And I always store everything as A. You can do whatever you want, but I recommend pick A. It's the first letter of the alphabet. It's right next to the alpha key. So do you see the A right there? So it's convenient. You're going to hit store, S-T-O, alpha A, enter. Store alpha A, enter. Store alpha A. I just say it over and over again. Store alpha A, enter. Store alpha A, enter. Okay. So now when you go to set up your integral, you can just put A. And then in the integral, we're going to subtract our rates. It's rate in minus rate out, dt. And that's what you're going to type in. And that will give you the number of people at the party when it is most crowded. So we found the time it was most crowded, and now we're going to accumulate people until that time. So how do I type an integral? Math 9, good. 0 to alpha A. It'll copy and paste that value in for you. And so how many people are there when it is most crowded? We can round to the nearest whole person in this case because it's people. Yeah, we'll say 25 people. So are there ever more than 25 people? No, that's our maximum, most crowded. B says, set up the integral equation that would give the time x at which everyone left, okay? So it's going to be an integral from 0 to x. We don't know that time, and we don't have to find it. It just said to set it up. Again, inside your integral, that's where your rates go. So it's going to be rate in minus rate out dt. So from 0 to some time, we don't know when that is. And we want this to equal, because it said set up an equation. You want it to equal what? If everyone is left, 0. When do you have 0 people? I don't know. But if you solved that, that's what that would give you. What is the net rate? Net rate just means you're going to subtract rate in minus rate out. You guys all work jobs. You know that your net pay is like what you made minus taxes. Like, okay, subtracting that out. What is the net rate at which people are arriving at time 4? All right, well, we're going to do rate in at 4. So 40e to the negative 4th. That would give you the rate at which people are arriving. And then minus the rate out, which again is just 5. And then type that in and you'll get your decimal answer. I didn't need to do a derivative because again, those are already rates. Like we were given the rates. And we don't need to round to a whole number because this is a rate, not like an actual number of people. Did you get negative 4.267? Okay. What are the units on that? If it's a rate, people per hour. And follow-up question, since that rate is negative, what does that mean is going on at time 4 hours? Because sometimes they ask you to explain what's going on at time 4. People are leaving faster than they're coming in. They like for you to compare them. They do that all the time. So at time 4 hours, like everybody's on their way. All right, what is important about this problem is initial position. It's where they both start. Every once in a while, the AP exam, they'll give you extra information you don't need. It will never be an initial condition. If they give you one, you have to use it. That will never be extra, okay? So where's the gopher starting? Negative 10, he's 10 feet below ground. Where's the monkey starting? 10 feet above ground. So one's at negative 10, one's at positive 10. They are moving towards each other. These are their rate equations and they are in feet per second. Use the units to help you. That's a clue. These are already derivatives. They're in feet per second. So find the positions of the two animals at time 3. All right, let's do the gopher first. We just said he starts at negative 10 plus he's moving upwards. And then we want to accumulate how far he's gone. What will be the boundaries on that? Good. It's always initial condition plus accumulations, where you started plus how far you went. And then in there, you're going to put g of t. I'm just going to write g of t. Obviously, when you type it, you'll have to type the whole equation, but just write g of t because then you can't do a copy error. All right, and then for the monkey, he starts at positive 10. He's moving downwards. So what do we put next? He's moving down. Plus or minus? He's moving down. There we go. If we accumulate how far he's gone, we need to subtract it because he's moving. Is this making sense? Like the integral tells us how far he went down. So we have to subtract that amount. Okay. And it'll be integral 0 to 3 of the monkey equation. So you guys in the front do type in m of t. You guys in the back do g of t. We'll divide and conquer to get our answers. And compare with each other and then let me know what you got. What'd you guys get for the gopher? Did either of you get an answer for the gopher? Yeah, it should be negative. Is that what you got? Okay, negative 5 point. Okay. Feet. So where is the gopher still? He's still below ground, but he's burrowed up like a good deal. All right. What do we get for the monkey?
6.7.
6.7 feet. And so he's still in the tree, but further down. All right, because they're moving towards each other. When are the two animals traveling at the same rate for the first time? How would you do that? Set them equal. G of t equals m of t. And I know this sounds silly. Always write stuff like that on your AP exam, because a lot of times it'll be worth a point to set those equal. Like if you set those equal, you get a point. Do you get what I'm saying? It's like the silliest little thing to get a point for. So write that every time, okay? So go to y equals, clear out what we had before. We're gonna put the gopher equation into y1, and then the monkey equation into y2. Ooh, whoops, not that though. And I always start with Zoom 6. We can adjust it from there if we need to. And actually, I think we will, because I'm gonna need to zoom in on that. Did you get something that looks kind of like this? Okay, we need to look at where they intersect. So I'm gonna need to zoom in on this little part of it. You can either do zoom in, or sometimes I like to have more control over it. So I'll go to window and adjust it. I'm gonna make them both 0 to 5. Again, that's kind of up to you. You just sort of need to mess with the window until you're happy with it. But I think 0 to 5 will be okay. I honestly don't know what this stuff is down here. I guess res is resolution. I don't know what that means. Anyway, graph, and I think we'll be able to see a little bit better this time. Okay. Do you see how there's two intersections?
Yes.
Which one do we want?
First time.
Yeah, the first time. So we're gonna hit second trace, intersect. Now it's gonna ask you first curve, second curve, guess. I usually just say hit enter for all those things, but here's the problem. For the guess, your cursor needs to be closest to the first one, because there's two options and it'll give you whichever one it's closer to. So I'm gonna hit enter for first curve, enter for second curve, but then for guess, you do have to move the cursor like closer. Do you get what I'm saying? Like it's gonna give you the one it's closest to. So if there's more than one option, you have to be a little bit more particular about that. I got 0.075. Right, okay, thank you for confirmation. So time 0.075 seconds. There's a follow-up to that one too. How fast are they going? So that's the rate at that time. Good news, these are the rates, and that answer is also on your calculator screen. What is the rate at that time? At time 0.075, our rate is, do you see that there, the 0.815? These equations are your rates, so that's your y value, 0.815. And what is the unit for the rate? Feet per second. When are the animals closest to each other? That's almost kind of a trick question. If you go back to the original problem, it says, look it, they are moving towards each other for
5 seconds.
So if they move towards each other for 5 seconds, when are they closest? 5 seconds. So that answer is kind of in the problem. They are closest at time 5 seconds. How close are they? Well, you have to find the gopher position and the monkey position and then subtract them, see how close they are. So I'm going to divide and conquer this again. Guys that did the gopher one, which I don't remember how I divvied it up. You guys did gopher. Okay, look up here. You're going to go back to this. You know how you can just hit up in the calculator to go back and just change the 3 to a 5. And you guys that had the monkey equation, just hit the up button until you get back to this and change the 3 to a 5 and hit enter. and it'll redo it for you. So you don't have to type the whole thing again. Were you able to find it when you typed up? Perfect. And I love talking about this. Okay, where's the gopher?
He's in the air.
Not only did he burrow out of the ground, he has now also started to climb the tree. One heck of a gopher. All right, and what'd you guys get for the monkey?
3.5.
3.5. Now the question again was how far apart are they? So you'd have to subtract those. So how close are they? I got 0.751 feet apart.
Yep.
They're pretty close. I wonder what's going to happen. So and then everyone always wants to talk about like who would win. I don't know. That's one heck of a gopher. He burrowed out and started to climb the tree. How big are gophers though? They're not all that big. Like, yeah. Yeah. Because when we, here, let me go back to the graph. Because these equations that we typed in are the rates. So we want the rate at this time. Let me recalculate it. Hold on. So at this time, this is the rate. Like it calculates both the X and the Y for you. So we actually had both of them on there. So again, these are the rate equations. And at this time, the rates were 0.815. They were going the same speed because it's where they intersect. Okay, here's where we get into what's technically particle motion. The only difference, it's the exact same thing that we've just been doing. The only difference is they use different vocabulary. They call it velocity for a derivative and acceleration for a second derivative, okay? And then we have these things, displacement, total distance, and position. Displacement is your integral from A to B of your velocity. And displacement is just where you ended up. For example, if I start here in this seat and I run down the hallway and I come back and I sit back down in this seat, what was my displacement? 0. I ended up where I started. But do you get that my total distance would be a lot more? Do you remember what we do? Because it's almost the exact same thing, but how do you make it a total distance? You absolute value it. And what that does is it treats all of your change as positive. Because displacement going down would be positive, coming back would be negative, and they would cancel out. But if you absolute value it, it treats it all as positive, and that gives you the total distance. Position, if you want to know where you ended up, you take where you start, the initial condition, the initial, well, I guess I'll say initial condition, plus the displacement. So it's where you started plus how you changed. That's going to give you where you ended up. I'm going to skip number 8 because I'll put these answers on Schoology again. I want you to have a little bit of time left over in the end. Let's just do 9 and 10. Okay. And 9 is very heavy on the calculator. So just make sure you're with me with what we're typing here. This is our hot air balloon again. I always come back to the hot air balloon problem. The rate of change in kilometers per hour for our hot air balloon is given by this. It's already a rate. It is a derivative, kilometers per hour, 0 to 4 hours. Where is the balloon starting out? Initially where? 0. That's your initial position is 0. Go to y equals, clear out what we had in there, and go ahead and type in that rate. And then pause for a second because I want to talk about the window. Because this one, we are going to be a little bit more particular about the window. So go to window. What do they give us as the time interval? Good. So make your x's 0 to 4. And then y's, I would start with -10 to 10 because that's standard. Again, you can always adjust from there, but -10 to 10 is always a good starting point. But you want your x's to be 0 to 4 because that's what they said. So hit graph, and then here's what I always get. The balloon started up in the air. No, it didn't. It started on the ground. This is not where it is. This is its rate. So this part is positive. That means the balloon went up. If it started on the ground, it had to go up, right? Okay. All this part is negative. That means it went down. And then this part's positive. That means it went. That means you do not want to exit the balloon at the end of these 4 hours because where is it? In the air. Okay. So that's what's going on. Letter A. When is the balloon closest to the ground? And then what is its altitude? Closest to the ground is a minimum. That's where your derivative changes from negative to positive. Do you see how right here we went from negative to positive?
Yeah.
How would we calculate this 0? Calculate second trace, 0. Now, it looks about 3.5. You with me there? All right, so for left bound, hit 3, enter. For right bound, hit 4, enter. And for guess, hit 3.5, enter. Or you can mess with the arrow. It's kind of up to you, but I feel like that's a little bit easier. All right, at what time are we closest to the ground? 3 point, yep. Yeah, you could write them all if you want to. Hours. Now, do you want to type all the decimals or do you want to store it? And it'll work either way. Some people don't like storing, and so they'll type all the numbers, and that's fine too. It should be accurate enough if you type them all. Do you want to type them all or do you want to go through storing? Oh, okay. Okay. I'm not going to ask you anymore. It seems like you guys like to store. Go back to the home screen, hit X, enter. That'll bring it back. Store alpha A, enter. I'm going to write those instructions on the board. Go back to the home screen, hit X, enter. Store alpha A, enter. So to get where the balloon is, you take where it started, which was the ground, plus its accumulation from 0 to A. I'm writing that 0 because it's not always 0, and it's important to know that that's there. It's where you started plus your accumulation. And then you're going to type that in. Oops, what the heck? I strongly dislike calculator problems. It's just all this button pushing. I got 1.348. Is that
Yes.
confirmation? Okay, and it's 1.348. It's where it is, so kilometers. That's pretty far in the air. What do you guys think? Should we switch to metric? It's not going to happen, but we're going to stick with our miles and our feet and our inches. All right. Find the value of integral 0 to 4. Explain what it means. Is it displacement or is it total distance? It's one or the other. It is. Why is it displacement? Not absolute value. Displacement in kilometers. And you have to say one other thing. You have to mention these boundaries. So it's displacement in kilometers from 0 to 4 hours. C is literally the exact same thing, except instead of displacement, you're going to put total distance in kilometers from 0 to 4 hours. Same exact thing. Those are like definitions. I can't change it. On your test, that's the answer. D, I'm going to not go through the whole thing. I'm just going to start you on it because it's exactly the same as A. When is the balloon at its maximum? Look, maximum is a change from positive to negative. Do you see this here? You would repeat the process we did for part A exactly, except you would use this 0 instead. See what I'm saying? You would do part A exactly like we did. You calculate this one, store it, and then go from 0 to A. It'll tell you how far in the air it is. Okay, so D is the exact same thing as A. because I want to have time to look at the last one because it's a table problem. I think, is this the one where I was silly about the units? Yeah. I got sick of everything always being feet per second, so I really messed with the units on this one. Can you read them and tell me what they are? I was just trying to keep everybody on their toes. Nanometers per decade, so it's like a glacier, I guess. Nanometers per decade. All right, we're given velocity, acceleration. I can't remember if we actually need the acceleration or not, but we'll see. Use a left Riemann sum to approximate this. Show computations. That just means write it all out. And then we'll explain what it means, okay? So here are your sub-intervals. There's only 3. What is the length of the first sub-interval? So 2. And then you would multiply that by what for a left sum? 5, good. The number on the left. Plus, what's the length of your next subinterval? 4. And then the number on the left? 3. And then the last one, 4 times -1. What do you do to that? Nothing. Okay. But we're going to say what it means. Is it displacement or is it total distance? Displacement. Displacement in nanometers. And then you have to say one other thing. From 0 to 10 decades. Is that greater or less than the, remember, over approximation or under approximation? So what is happening to these velocity numbers? 5, 3, -1, -8. What are they doing? They are decreasing. I usually just put my pencil on the paper. Decreasing. It's going like this. We did a left sum. This is the left side. Overestimate. Perfect. Overestimate because, and then there's 2 things that you have to mention. Because it's a left sum and decreasing. And I know this sounds like I'm being super nitpicky, but you can't say it is decreasing because there's 2 different functions that we're talking about. So you have to say v of t is decreasing. I hate to tell you, but they won't give it to you because if you say it and there's 2 different functions, they don't know, like you have to name it. Approximate this using, trapezoidal approximation. And we're going to treat every number like it is positive. Okay, so 1/2. Our first subinterval was 2. And then it would be 5 plus 3. I'm not going to move my paper up and down anymore because I don't want to make you seasick. But what would the next one be? 1/2 times 4. Good. And then plus 1. Perfect. Because we're going to treat it like it's positive. And then the last one, 1/2 times 4, and then 1 plus 8. It says explain what it means. I'm not going to rewrite it. It is exactly what we wrote right here, except instead of displacement, you would say total distance in nanometers from 0 to 10 decades. And the reason it's total distance is because of the absolute value. So because it's absolute value, we treated all the numbers like they were positive. You just don't do any negatives. And then this one, it feels for 1 second like you would need to use those A of t values, but you don't, because integral and derivative cancel out. So your integral, like your antiderivative of A of t would be V of t such that 0 to 10. And then it's upper boundary minus lower boundary. So all those A of t values were extra. They do that sometimes, like they'll put a whole column in the or row in the table that you don't need. So what's V of 10? What was that on the table? V of 10, -8, minus, and then what was V of 0? 5. So that would be -13. And explain what it means. It's negative. So is the rate increasing or is the rate decreasing? Decreasing. The rate is decreasing 13. I'm sorry, that looks like a B. Let me fix that. 13 nanometers per decade from 0 to 10 decades. So not only is this object, whatever it is, moving incredibly slowly, it's also doing what? Yeah, it's also like going ever more slowly as it goes along.